Welcome to session 5 of Real Analysis. In the previous sessions, we have covered the topics like countability, finite sets and infinite sets. We have seen that the set of all natural numbers, the set of all subsets of natural numbers and the set of all rational numbers are all countable. In today's session, we will be discussing some more properties on the numbers which are real numbers. The first property that we will be looking at is the algebraic properties of R. On the set R of real numbers, there are two operations defined, namely addition and multiplication of numbers satisfying the following properties, namely the first one is commutative property, where A plus B is equal to B plus A for every AB belonging to R. That shows that if we add two real numbers, the order in which the addition is taking place is immaterial. It can be taken in any way. The second property is what is called the associative property, where we have three real numbers A, B and C, where A plus B plus C is equal to A plus B plus C for every A, B, C elements of R. So, again this property shows that the order in which three real numbers are added can be in any order. That means, the first two can be added and then added to the third number, or the first can be added to the sum of the second and third. This property is called associative property. The next property shows that there exists a unique real number 0, which when added to any real number A gives the same real number A itself. That is, 0 when added to a real number A is equal to A, and because of the commutative property, we have 0 plus A is equal to A plus 0 as well. Even otherwise, even if the commutative property is not there, the identity element 0 will always have this property, that is, identity operated with any element or any element operated with identity gives the same element itself. Then comes the property called the existence of inverse, where we have for each A element of R, there exists a unique inverse element negative A belonging to R, such that negative A plus A is equal to A plus minus A is equal to 0. We usually call this as minus A or negative A. That is exactly the same. So, this is called the existence of inverse. So, these are the properties with respect to addition, and now we have the properties with respect to multiplication, namely commutative property. If any element A is multiplied with any element B, it can be taken in any order. That means, A dot B is equal to B into A for every AB elements of R. That is, the order in which multiplication has to occur in real numbers is immaterial. We can take A into B or B into A, both gives the same answer. The second property is what is called the associative property, where we have three elements A, B, C in R, and the order in which they can be multiplied is also can be any order. A into B multiplied with C is equal to A multiplied with the product of B and C. Then, like we had a 0 in the case of addition, we have a number 1 element of R, such that 1 into A is equal to A is equal to A into 1 for every real number A. That is, 1 is called the multiplicative identity. 1 when multiplied with any element gives the same element. And as we had negative A for addition, we have 1 by A for multiplication for each A element of R, provided A has to be non-zero. If A is equal to 0, we all know that division by 0 is not defined, and so there is no multiplicative inverse for 0. All the non-zero real numbers do possess a multiplicative inverse in R, which is called 1 by A. so that A into 1 by A is equal to 1, which is equal to 1 by A into A. And the last property, which is a combination of addition as well as multiplication, is what is called the distributive property, where we have the sum of two numbers A plus B multiplied by C is equal to the sum of the products of A with C and B with C. Also, we have the left, this is called the left distributive property, and this is called the right distributive property, where we have A into B plus C is equal to A into B plus A into C for every A, B, C belonging to R. So, both distributive properties also hold for the real numbers. For example, we can see the first property that we have learned is commutative property for addition. We know that 1 plus 2 is equal to 3, which can be replaced as 2 plus 1 as well. Then for every real number A, B, C, we have the associative property, where we have say 1 plus 2 plus 3 is equal to 1 plus 5, which is equal to 6, which is same as 1 plus 2 plus 3 is again 6. Likewise, we have any real numbers added in any order gives the same result. Then we have 1 plus 0 is equal to 1 is equal to 0 plus 1, and for every real number A, or for every real number say half belongs to R, we know. Therefore, there exists a minus half belonging to R, such that half plus minus half is equal to 0 is equal to minus half plus half as well. So, this holds for every real number. I am giving only examples.